Welcome back. In this video, we're going to draw the sword for our knight. We're going to use a weapon texture, and we're going to use Draw Texture Pro to draw the sword to the screen. Now, Draw Texture Pro uses something called an origin, and we're going to take a closer look at that. So, Draw Texture Pro takes a vector 2 called origin, and this behaves as the origin for the texture that we're drawing. Now, if we choose 0, 0 for the origin, that's going to be the upper left corner of the texture, and this gives us a point of reference when it comes to scaling and rotating. We're interested in rotation since we're going to want to swing the sword. Now, choosing this point as the origin, if we rotate the sword, it's going to rotate about this point. Now, if we instead chose the lower left corner of the texture as the origin, that's going to be 0 for the X and height for the Y, where height is the height of the texture. Choosing this point as the origin allows us to rotate about this point when we pass in a rotation value to Draw Texture Pro. Let's draw the texture and see what we can do about the origin. So we're here in character.h, and I'm going to add a new private variable of type texture2d called weapon. Now I'm going to use braced initialization and initialize this here with load texture. And the texture I'd like to load exists in the characters folder, and it's called weapon sword.png. We'll see what this looks like as soon as we start to draw it. Now we can draw this texture in the tick function. So in characters tick, we're going to go down to the bottom after everything else, and we'll put a comment that says draw the sword. Now we're going to use Draw Texture Pro, which requires two input parameters of type rectangle. So we can make these rectangles here. The first we'll call source, and for the X and the Y we'll use 0.f, and the width and height are going to be the width and height of the weapon texture. So weapon.width and weapon.height. Now these are integers, so we're going to use static cast, and we'll cast these to float values. So there's our cast for the width, and here's our cast for the height. Now as we've seen, we can scale the width by right-left, and this will cause the texture to flip in the x-axis. So we're going to multiply the width by right-left. Now for the rectangle called dest. Now the X and Y on dest are going to be the screen position to draw this texture. For now, let's just use screenpos.x and screenpos.y. This will be the screen position for the character. Now width and height for dest are going to be the width and height that we wish to draw the texture at, and we'd like to scale this texture up. So we're going to use weapon.width times scale and weapon.height times scale. Now when you multiply an integer by a float, the result returned by this multiplication is a float value, so we don't need to cast this to a float. Now let's call Draw Texture Pro. So Draw Texture Pro takes a texture, we're going to pass in weapon, it needs the source rectangle as well as the dest, and then we need the origin vector. So for now, we'll see what happens when we pass in an empty vector, and for rotation, 0.f, and for color, we'll use white. Let's hit run and start debugging to see what this looks like. So here's our sword, and it's facing the right when we're running right, and it flips to face the left when we're running left. So this is a good start, but the position is all wrong. The upper left corner of the sword is the same location as the upper left corner for the character texture, so we need to fix that. Also, I'd kind of like to turn off the enemy's chasing behavior while we're testing this out. So let's go ahead and open the enemy.cpp, and so we can actually comment out the call to the base character tick function, and not only will the character no longer chase us, but we won't even be rendering the character, so we're essentially turning it off. Now back to the character. Let's think about our origin for a second. We'd like our origin to be the bottom left of the texture when we're facing right, but we'd like it to be the bottom right of the texture when we're facing left. That way we can rotate about those axes when we're swinging the sword. So before we declare our source and dest rectangles, we're going to have an if statement that checks to see if right-left is greater than 0.f. This means we're facing the right. and we'll have an else case for when we're facing left. Now we're going to want a vector for the origin, so we'll declare it just above the if statement. It'll be a vector 2 called origin, and we'll use braces. Now if we're facing right, we need the bottom left corner of the texture. So we'll set origin equal to 0.f for the x, and we want the weapon height. It's going to be weapon.height, and we need to multiply this by scale since we're scaling it up. Now in the else case, we want the bottom right. So in this case, x will be weapon.width. So we'll have weapon.width times scale. Now we're also going to want to offset the sword. So let's make another vector 2 called offset. And we'll add this offset to the dest rectangle. So screenpos.x will get offset.x added to it. And screenpos.y will get offset.y added to it. And in the if statement, we'll set offset. So here, we'll set offset to a value, and through trial and error, you can find appropriate values for these. I found that 35.f and 55.f is a good offset for when we're facing right. And for when we're facing left, I found that 25.f and 55.f is a good offset. So now that we have an origin, we can pass it in instead of an empty vector. So we'll pass in origin, and let's hit run and start debugging. And now we have our sword at a pretty good looking spot. And if you're not happy with this location for the sword, you can adjust the offset. Now we need to think about a collision rectangle for the weapon. We can visualize rectangles by using a raylib function called drawRectangleLines. Now this function takes a number of parameters, including position and dimensions, as well as a color. Now let's see what rectangle we get when we use screenpos plus offset, along with our weapon dimensions times scale. So we'll copy the input parameters for the dest rectangle, paste them in here, and our last parameter we need is a color. We'll use red. Let's run this and see what we get. Now here's our rectangle. The reason it's not at the same location as the sword is because we chose our origin for the sword to be the bottom left corner. But drawRectangleLines takes the location you give it and uses that for the upper left corner. So if we want a collision rectangle for the sword, we'll need to move this rectangle up by the height of the texture. And when we're facing left, we'll also need to move it left by the width of the texture. So let's create a rectangle on character.h called weapon collision rec. So this will be a rectangle, and we'll call this weapon collision rec, and we'll set this in the tick function. So first, when we're facing right, we'll set weapon collision rec equal to the value of screenpos.x plus offset.x, and y will be screenpos.y plus offset.y minus weapon.height times scale. Now width and height will just be the width and height of the texture, so we'll use weapon.width times scale and weapon.height times scale. There's our semicolon. Now let's copy this and we'll paste it in the else statement for when we're facing left. Only in this case, we also need to subtract the width for the position, so we'll say minus weapon.width times scale. Now we have this weapon collision rec. Let's draw this with our drawRectangleLines. So for x, we'll use weapon collision rec.x. For y, we'll use weapon collision rec.y. For width, we'll use .width. And for height, we'll use .height. And we'll draw this rectangle with red as color. Let's run this now. And now we have a rectangle that exists at the same location as the sword. This will come in handy when we need to do collision checks when we're attacking. So now we're drawing a texture and we're using almost all the input parameters. The only thing we're hard coding here is the input parameter called rotation. But since we set up our origin correctly, we can rotate this sword if we want to. So here's your challenge. In the character's tick function, just under our origin and offset local variables, create a local float called rotation. In the if statement, if right left is greater than 0, set rotation to a value of 35.f. And in the else case, if right left is not greater than 0, set it to negative 35.f. Then pass this in to Draw Texture Pro instead of 0.f. Pause the video and do this now. Okay, so we're going to scroll up, and just under our offset local variable, we'll create a local float called rotation. And we'll use braces. And here in the if statement, we'll set rotation to 35.f. And here in the else statement, we'll set it to negative 35.f. And finally, in Draw Texture Pro, instead of 0.f, we'll pass in rotation. Let's run this. And now we see that when we're facing right, the sword is rotated clockwise a bit, and when we're facing left, it's rotated the other way. And that's thanks to setting our origin at the bottom left and bottom right corners, respectively. This will come in handy when we want to swing the sword for an attack. So in summary, we drew the sword in more ways than one, and we also used Draw Texture Pro to do this. We added a rotation parameter so that we can rotate thanks to our choice of the origin for Draw Texture Pro. Great job! In the next video, we'll work on making attack mechanics for the character. I'll see you soon.